Okay, welcome to Credit 7 Day 3. You are offered this little lottery prize, so there's two different options. You can have the $10,000 now or $20,000 10 years from now. And what we want you to do is to explain which of the two payoff methods you would choose. Would you like the $10,000 now or 20,000 10 years from now? And then we throw a little kink into it to say you can get 8% interest compounded yearly on that $10,000 if you take it now. So how does that affect your choice in the payoff method? And then we get a little bit deeper and actually talk about, what is the difference when we have that 8% interest each year. It's a pretty high interest rate. I don't think you can find that option today. But so what happens is the $10,000 plus 8% times the 10,000, which is really the same as just saying 100% plus 8%, right? 1.08 times 10,000, which is 10,800. And then that new amount for the next year gets added to 8% interest. And so it's the same as multiplying by 1.08, 100% plus 8%. And you get this new equation, which gives you that amount. And then this amount would be your new starting value plus 0.08 times the starting value. And so it just repeats itself each time you're multiplying by 1.08, which is an exponential function, right? So go ahead and look at that and see how it changes that 10-year plan. How much money will it provide at the end of 10 years? Will it be better than that 20,000 or not? And go ahead and answer those questions. And you might even want to make your own table and graph to estimate the solutions for these following equations. So at what time X will it be $25,000? At what time X will it be 37,000, 50,000? And you might want to just put this into GeoGebra. So you could say, Y equals this, 10,000 times 1.08 to the X power. Put that into GeoGebra, and then you could try these different values. So X equals 25,000. Go ahead and put that into your input bar, and it will give you a vertical line at 25,000. And then you could see, oh no, we want to do Y. Yeah, Y equals 25,000. So then you can see at what X value the total amount turns to 25,000. And you can say Y equals 37,000. See what X value this function will hit at, and so on. Then you're going to have a couple more savings plans to compare. So 15,000 earning 4% or 5,000 earning 12%, and then compare those to this other one, 10,000 at 8%, and write a summary of your findings. So you might want to put this into GeoGebra as well. So maybe Y, or you could use f of x or g of x or h of x if you want to have three different functions going at the same time. So this would be 15,000 times 1.04, right? 1.04, so 4%, 1.04 to the x. And the other one would be 5,000 times 1.12, right? 100% plus 12% each year gets compounded. So go ahead and make those functions and then make your comparison. So like, this is going to be better. Maybe this one's better if you have it in for a long time, or this one's better if you're going to pull the money out at a certain time. So you can compare those results. Okay, next we have, this is actually going to be the decay part. So before we were talking about growth, now we're talking about decay, and decay means it's actually going down. So this is talking about how a golf ball, when you drop from a height of 27 feet and it hits the parking lot and it bounces back up, right? So how high does it bounce back up? It doesn't bounce back up to the full 27 feet. It's going to be, it says 2/3 of the drop height. So at each step, it's going to reduce by 2/3. And that's the same as multiplying by 2/3. So this is still kind of in the realm of exponentials, but now it's exponential decay rather than growth. So every time you multiply by 2/3, so this would be 2/3 times 2/3 times 2/3 is just repeated multiplication, which is the same as exponentiation. But it's starting at a height of 27, right? So 27 times 2/3 to the x would be this function. So go ahead and graph it, and I would recommend that you graph your y-axis at a step of 2 and graph your x-axis at a step of 1. That way it'll fit on the graph nicely. Okay, so you can answer those questions now. And then we get to another softball instead of a golf ball. So the softball dropped at a height of 10 feet, rebounds 3.8. So what are we multiplying by each time? So you might compare, a couple of steps. How does this change each time? What are you multiplying by? And then you're going to watch this GeoGebra video on how to do an exponential decay function and put that in there and play around with it. So you'll have some points here, and you're going to figure out exactly what is the best fit option. And then you're going to put this into GeoGebra and answer those questions. Okay. And more GeoGebra questions. And answering some questions in your notebook. Okay, so that's it for today. See you tomorrow.